The world of quantum mechanics has shown us that elementary particles have a dualistic nature, and they have certain mathematically consistent uncertainties that are unique only to the quantum world. But could it be possible that other macro systems could in fact have similar properties? Schrödinger's equation offers mathematically consistent calculations that show that all atoms and bodies of atoms in our universe represent orbital zones where a location distribution of electrons around nuclei have a mathematically regular probability. The atomic orbital is defined as the region within the atom where the electron is likely to be found 90% of the time. Schrödinger's equation for an atom approximates where the atom's electrons will be found by calculating for both its electrons' kinetic and potential energies. Heisenberg's uncertainty principle states that the position and the velocity of an object cannot both be measured exactly at the same time, even in theory, and that the very concepts of exact position and exact velocity together are actually meaningless in the natural world. The two values are, however, inversely proportional, meaning that the more we know about one measurement, the less we know about the other, and vice versa. And the uncertainty of position multiplied by the uncertainty of momentum must be greater or equal to some constant. Emergent systems of all sorts occur all the time and in various time frames in our universe. Some are very quick, such as the forming of an atom after the Big Bang, or the forming of a snowflake, or a wink of an eye. In order to study these phenomena in detail, we need to in some way cognitively slow them down. For example, synaptic regions inside animal nervous systems have a location distribution of neurotransmitters around their neural synapses, whose probability of occurrence is very regular throughout the animal's life. This is a world of uncertainty with its own set of mathematically precise consistencies. Synaptic regions represent a subgroup of all chemical signal transductions in an organism, with a probability distribution of where certain chemicals will be found if we stop time and made a measurement. All the synapses in one's body represent its synaptome. Different synapse subtypes have unique anatomical distributions and features, with distinct signatures in all brain regions, and they all have one feature in common. They can create rapidly moving electric rises and falls along their cell membranes called action potentials. Many equations, such as the Nernst equation, calculate various properties of action potentials in cells. Action potentials always come in the package with the cell's synaptic signal transductions, as they are a direct result of these biochemical reactions and they co-evolved together. A reflex is a good example, or a hand wave, and all these recur regularly throughout an organism's life. As opposed to the functioning of the atomic orbital, whose waves we cannot even see without high technology, the pulse, or the wave of each recurring action potential is usually milliseconds long, and we would need to slow it down to be able to visualize it in real time. Conversely, certain emergent systems occur very gradually, such as the opening of flower petals, or the functioning of a large military operation, or the growth of an adult mammal organism. These systems we need to speed up rather than slow down in order to visualize their cycles better and understand the way they emerge. A whole new domain of uncertainty emerges when macro living systems composed of one or more living organisms is sped up. Let's do a little thought experiment. Imagine if a day of all the movements of an animal were squished into a span of 1 second. The GPS cat collar research from Lithgow, Australia, gave us snapshots of their domestic cat's daily movements and whereabouts. Notice how, with just one day of filming, a blur or a cloud of their overall position starts to emerge. Notice also how each cloud ends up with its own unique set of cat location probabilities, where each cat will be more likely to be found in within the town area. The cloud is always the busiest within the cat's home base, and especially around its favorite sleeping spot where it spends most of its time. Now imagine an accumulation of 1 full year of all the movements of these cats, with all their ingrained habits in a span of 1 second. The blur only gets more solidified as time passes. In the same way, let's now observe a hypothetical household with 2 parents and a child by speeding the household up to 1 year per second. First thing to notice is that this sped up reel of speedily moving humans would be filling the overall household cloud in very regular intervals, creating various pulses of activity. For example, both parents and the child are likely to be found in their beds every night, sleeping through 365 regular intervals equally spaced within our second, and each about 0.8 milliseconds long, altogether adding up to almost an entire 1/3 of a second of sleep within our hypothetical second, all the while making the resting areas, such as beds, much more densely populated than the rest of the more dispersed cloud of movement within the house. Our statistical high confidence in this number would directly correlate to the accumulated number of times a person would in fact be in their bed. If we were to listen to the frequency of the wavering shifts between wakefulness and non-wakefulness of this household system, and for that matter, the entire city it may dwell in, we would hear a dominating note with a pitch of about 365 Hz. There would also be other frequencies coming from certain minority of individuals with different sleeping patterns and quite literally not in harmony with this norm. If we were to let our hypothetical seconds run their course, an average human life would be just over a minute long. We could trace the note the human life would play during its existence, springing from zero activity straight into triple the frequency pulse during the baby stage, where sleep averages at a few times a day, and then very quickly flattening at the frequency of a 1 per day sleep schedule, a solar orbiting frequency that was there already when life itself was merely taking its first baby steps. Basically, one's entire 1 minute life would sound like a very stable 365 Hz note, but with a very short high-pitched blip right during birth. And let's not forget that besides the regular nighttime sleep, many societies have also adopted some form of an afternoon siesta, creating a quieter offset note with that same 365 Hz frequency caused by all the collective afternoon naps that would likely create an interesting chorusy effect in our hypothetical note. But we digress. Back to our household hologram. As already discussed, Schrödinger's equation defines the atomic orbital as the region within the atom where the electron is likely to be found 90% of the time. Similarly, we can also quite accurately predict where most individuals in our household would be found 90% of their waking and non-waking hours. Also, as mentioned, Schrödinger's equation for an atom approximates where the atom's electrons would be found by calculating for both its electrons' kinetic and potential energies. We can similarly write a hypothetical equation for our household hologram by calculating for human dormancy and rest as our potential energy and wakefulness and movement as our kinetic energy, all consistently carried out by our nervous system in the aim of getting one or another need met. We are bound to see an emerging blur when we look with our naked eye at a full year's worth of household movement flash by in a span of 1 second. It is biologically impossible to see and trace where exactly any household member would be at any given moment. Realistically, our eyes can maximally process smoothly up to about 150 frames per second, where each frame would already be a blur made up of about 2.5 days worth of each individual household member's movements. A blur similar to the cat movement blurs we already saw, slowly emerging a sketch of probabilities for different locations where each household member is deemed to be found, while going through 1 full year's worth of their habituated routines. Ultimately, our eyes don't have the resolution to see a whole year in 1 second, nor do we have the cognitive capacity to comprehend time that quickly, as our brains never naturally selected for that ability. But that is okay, as this blur in fact carries certain other important information about the household's overall physical whereabouts, information that essentially represents the entire yearly momentum of each individual's presence and agency in the house. This is how we can see an uncertainty in the macro world, with macro objects, where particles are much bigger than atoms and electrons, and where we can physically see these large entities. We simply need to observe their movements through much longer periods of time. This is actually how our memory works in the first place. It is precisely the accumulation of experiences throughout the years that allows us to observe these clouds. For example, when we get to know whether we can count on someone or not, or whether someone has been crying wolf or not all these years, or whether a certain bike route is better than another route. This is also what statistics are in their essence. They are 4D paintings that show the emergence of different phenomena throughout time. String theory has already described elementary particles as different string-like vibrations of motion. Hypothetically, these could be incredibly small particles that move so fast they leave a string trail behind them, leaving us with a small probability cloud called an orbital. Ultimately, an electron's presence acts as much as a probability wave in a split of a second of its existence as your presence acts as a probability wave in one full year of your existence. These pulsating clouds don't represent velocities of individuals in one moment, but rather they represent the overall mean velocity of all velocities performed by each individual throughout the entire year. We can even go as far as thinking of each person's cloud of existence as their inherent spirit. If we were to now artificially start slowing it all back down, a different picture emerges. We can now start to notice certain consistencies and rhythmical repetitions, showing us where the household members would be located in the span of each second. And we can start to be able to give increasingly more accurate predictions as to who is where at any given moment, especially when we slow it down to real time, which is our default everyday experience of the world. The more we slow down, the more we can know about individuals' positions, but the more we lose about the individual's average movement. Now imagine if instead of slowing the reel down, we abruptly stopped our year per second reel and instantaneously turned this cloud into one instance. We would essentially end up with a freeze frame picture of the household at a certain point in time. Since human sleep hours are approximately 1/3 of the day, there would approximately be a 30% chance that when we stopped the reel, the family would be in their beds, sleeping, making their resting place the densest area of the overall orbital of their existence, the place around which all their waking hours revolve around. Of course, once we have frozen the frame, we cannot possibly know where, how much, or how fast each individual would have moved within the household in a span of the entire year. We could see where the person would be at any given moment, but the picture would not show what the person's daily routine would be. With the freeze frame, we'll lose the cloud. In essence, just like Heisenberg's uncertainty loses the electron's momentum value when making an observation, when we look at only one frame of the household, we cannot know the overall yearly momentum of any of its members. In order to truly allow our eyes to see the household in real time, in one position without the presence of a fast snapshot camera, the household members would need to be instructed to stay motionless for the whole year, or at least for a few days, giving us one functional frame that our eyes can physically detect. Essentially, an agency of same or similar frequency rate of activity would need to interact with the household in order to show us their members. This is why it is impossible and meaningless to know people's whereabouts if they're stuck in one same spot. This is in a sense the same reason why elementary particles cannot be observed without being disturbed, because if we can see it, that means that a photon that carries the information to our eyes had already interacted with what we're looking at. In this context, humans and all other animals do operate in a system that is dualistic in nature throughout spans of ages. On one hand, we're mere particles, specks moving through our universes, and on the other, we are also a vibration, a very slow vibration with a rather long wavelength, but a vibration nevertheless, driven and mandated by the universe around us, a vibration that can very much be defined through some probability function. And just like in Heisenberg's uncertainty, here also the very concepts of knowing both one's exact position in a chosen moment and knowing one's yearly whereabouts at the same time are also meaningless. Instead, their values are also inversely proportional. The uncertainty of our yearly position multiplied with the uncertainty of our overall yearly momentum, would also have to be greater or equal to some constant. We may not be able to observe quantum mechanics in real-time, day-to-day experiences, but we can observe them when they stretch for years, day in and day out. Let us now look at an even larger scale picture. Just like atoms with their electrons are mere subcomponents of their relatively large-sized molecular systems, similarly, humans and the neural networks that fire within them are merely subcomponents in their relatively large-sized societies. Despite spending a fair part of their existence sleeping in their beds, individuals would not be found within their household during a large portion of the second. They would have various probabilities of being at one place or another. The house merely is just a home base, out of which all the other areas are traveled to. Imagine if we were to speed up one entire city. What would we actually see? The birds in their flight would fill the transparency of the sky into an overcast layer. Marine life would swamp the oceans and rivers, turning them into a big continuous blob, and all land animals would cover the Earth's surface like a crochet, with metal human-made airplanes creating sharp steel tubules with streams of living human bodies within them. Traffic systems in multi-level human societies would appear like veins in a multicellular organism. Different animals would find themselves passing through the same places other animals had ventured to, creating constant intersections of organisms, all equally immersed within the Earth's elements around. All the while, the city itself would have a variety of its own pulses. It would flicker like a strobe with its 365 moments of activity between nightly rests, and for each second, the seasons would take a breath. Holidays and festivals would all be flashing by, and migrating animals would be pouring in and out. And within all members of the society, each cultural meme would get physically and structurally realized and reinforced as a neural schema a million times over. Because of its large size, even when we speed up a large society to a second per year, we can still very easily see its overall movement and have a very high confidence in and large certainty of its whereabouts. A picture of a city always looks more or less the same. In fact, watching any cultural system sped up year in and year out would make societal stratums look like moving bacteria, or even multicellular tissues, be it a small traveling circus that visits for a season, or stratas of new family homes that get built in suburban areas, expanding the city's perimeters. Or be it entire empires, with borders moving across continents, with kingdoms living and surviving, consuming other state territories and implementing their laws and norms. Ultimately, each country unfolds a life of its own, while taking directions from its own rules and laws. When we look at larger systems, its components actually lose their individual significance. They merely play a role for their larger system. Just like there's pretty much a full turnover of atoms in an organism every 5 years, there's also pretty much a full turnover of individuals in a society every 100 years. Yet, the systems continue to run and function successfully. Fundamentally, the bigger the system gets, the slower the frequency of its emergence becomes. Our brains need to speed up cultural societies, as well as large celestial events, in order to be able to see them move in real time. That is, in our real time. Their events exist and operate in a level of emergence that is a degree higher than ours. This is why, even according to our definition in this video, the concept of the spirit would hold such high regard in so many societies. Wisdoms of the ages are quite literally a rooted product of a world from a higher dimension. All the while, we humans, who are mere building blocks of societies, together with other animals around us, still move in real time, in our domain of emergence, with our brains naturally selected for the ability to comprehend our real-time events extremely well. Now, building blocks of organisms themselves are yet in another lower degree of emergence from our own. In this case, in order to see the movements of biomolecules and biochemical processes of living systems in our real time, we need to slow them down, quite significantly in fact. Moreover, The building blocks of molecules and atoms themselves are yet another lower degree of emergence removed from our real time. It is a degree that is evidently just a wee too removed from what our brains have evolved to comprehend. There was never a need for animals to evolutionarily select for keeping track of the ongoings in the quantum micro world. Our brains were given a pocket of comprehension somewhere between the inability to imagine something extremely small moving at a speed of light and the inability to imagine large galaxies moving through spans of billions of years. Our brains mainly evolved to understand real time. This is why we cannot easily explain any concept without bringing it into our real time. All these processes, whether quantum or macroscopic, chemical or cognitive, are not only predictable but consistently reinforced. And no matter how perfect these worlds have come to be throughout the ages, no matter how ingrained and predictable, each one of them will still have subtle variations, errors, mutations, fluctuations, probability waveforms. No matter how perfectly a system evolves, it always inevitably holds a dose of random. Thank you for watching. This is the first video out of many that I will be making, exploring worlds of matter, life and culture, discussing different established ideas, and proposing various new ideas and hypotheses. If you like what you learned, please subscribe, and if you like to see more videos like these, you can support the channel through Patreon. All links are in the details below.